Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about liquid state, and I have already uploaded 3 videos on liquid state. So before watching this video, you have to go to the previous video, 3 video, so that this topic will be very clear to you. My friend, today in this video we will learn about viscosity. So what is viscosity? This is a properties of a liquid. You can see the definition here. A liquid may be considered to be consisting of molecular layer. What does it mean? A liquid may be considered to be consisting of molecular layer. So you know the word layers, you know the molecules. So molecular layer arrange one over the other, and that is very important point you have to understand. Now, when a shearing force is applied to a liquid, shearing force is applied to a liquid, it flows. However, the forces of frictions between the layer, focus on the molecules, focus on the layers. Layer is the physical phenomenon, molecules coming from the chemistry. And this is the concept. The frictions between the layers offer resistance. Resistance word is also very important. Resistant to this flow. Now you can understand this pictorial diagram. With the help of this, you make your concept about the viscosity. Viscosity of a liquid is a measure of its frictional resistance. Focus on this frictional resistance. Look at here. Moving plane and stationary plane. Moving plane and stationary plane. And this is your molecular layers. So if it is moving V, at a stationary pair, V is equal to 0. So this is the velocity profile. So flow of liquid on a glass surface. Imagine you have the liquid in the beaker. So next pictorial diagram, which is more clear to you, you can see. Consider this area and this area. This area is V, and then this area V plus dV. So this is your dx. So two parallel layers moving in a liquid. Two parallel layer moving in the liquid. This is very important and to understand what is meaning of V here. One layer, another layer V plus dV. You have the area, and the differences between this layer is two parallel layer is dx. So consider two adjacent moving layer of a liquid separated by a distance dx and have velocity differences dv. This is very important. You have to focus on this dx and dv. And the force of the frictions F resisting the relative motions of the two layers is defined with the mathematical formula directly proportional to A dV by dx, and F is equal to eta A dV by dx, and eta is equal to F by A multiplied by dx by dv. So where eta, Greek letter eta, is the proportionality constant, and it is known as the coefficient of viscosity or simply viscosity of a liquid. Now eta has a specific value for a given liquid at the same temperature. The reciprocal of viscosity is called fluidity and denoted by phi. The reciprocal of the viscosity. Try to understand. Reciprocal of the viscosity is called fluidity and is denoted by phi. Now, the viscosity decreases with increase in temperature, like surface tension. You have to look out the viscosity units because it is also very important. The unit of coefficient of viscosity eta may be derived from the equations 2. So eta is equal to F divided by A multiplied by dx by dv. Now you have the force, you have the area, you have distance, you have velocity. So put the all physical quantities unit, mass into length into time inverse 2 divided by length square multiplied by length per time. So this is your eta units. Thus in CGS system the unit of eta is expressed as like this and it is called poise P. In particular smaller units centipoise and millipoise like this. This is an SI unit is kg per meter per second. Now 1 poise is equal to 1/10 of the SI unit. For the conversions you have to 1 poise is equal to 1 gram per centimeter per second and this is the 0.1 kg per meter per second. Now you have the variety of liquid here: benzene, carbon tetrachloride, ethanol, ether, glycerin and water. You have the viscosity in CGS system, viscosity in SI units. Now look at this table and think about it. The measurement of viscosity by Ostwald method. How you will measure the viscosity? You know the viscosity of liquid can be determined with the help of Paisuli equations eta pi pr 4 T and 8 LV. So where V is the volume of liquid flowing through capillary in a time T, P the pressure, R is the radius of the tube and L its length. The experimental measurement of P, R, L and V offer considerably difficulty. Therefore, it is not possible to find the absolute coefficient of viscosity eta straight away from the Paisuli equations. So, the viscosity of liquid is determined with the speed to that of the water and this is called relative viscosity. So, let T1 and T2 be the time of flow of the fixed volume V. The two liquids through the same capillary. The expression of the relative viscosity now differentiate into N1 divided by eta 1 and divided by eta 2 can be derived with the form of Paisuli equations. You can see here. So, substituting value of viscosity of coefficient of water eta 2, we can find the absolute viscosity of the given liquid and eta 1. Now you can see the poured liquids and suck here. This is for the sucking and this is for pouring. You have the A and B, these portions, calibrations marks here, this ring and this ring, you can see. Now you have the capillary tube, you can see here the capillary, and this is the liquids. So A and B, you can see this bulb and this bulb. So this is the Ostwald viscometer. Now experiments. A definite volume of liquid, say 25 ml, is poured into the bulb C with a pipette. The liquid is sucked up near to the top of the left limb with the help of rubber tubing attached to it. The liquid is then released to flow back into the bulb C. The time t1 from A to B is noted with the stopwatch. So you need a stopwatch for performing these experiments. Then the apparatus is cleaned and the experiment repeated with water, taking about the same volume. The time of flow of water T2 from A to B is recorded. The density of the liquid D and water dW are determined with the help of pycnometers. So the relative viscosity coefficient is calculated from the expression N in water is equal to d T1 d water T2. So knowing the value of viscosity coefficient of water at the temperature of the experiments, the absolute viscosity coefficient of the given liquid can be found. So you can see, if you know some parameter, then you calculate the absolute viscosity. Another solved example. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching. In next video, I will talk about the refractive index, and this is also very important physical phenomenon for the liquids.